Hello, students. Today, we are going to begin a very interesting chapter on chemical reactions and how we write them. Have you ever wondered what happens when milk is left out on a warm day and it becomes sour? Or when you see a shiny iron nail that turns all rusty? Well, these are all chemical reactions, and in this explainer, we're going to understand exactly how we describe them. So let's start by just looking at some changes that happen all around us, in our daily lives. Just think about it. What happens when milk is left at room temperature during the summer, or an iron tawa or pan gets rusted? Think about the process of cooking food, or even how food gets digested inside our body. And of course, the very act of breathing when we respire. So, what is the common thing in all these situations? Well, the main point is that in every single case, a completely new substance is formed. The original substance has changed into something different. This transformation, this is what we call a chemical reaction. In today's lesson, here is what we are going to cover. We'll begin with the language of chemistry. Then we will learn the very important skill of balancing chemical equations. After that, we'll look at two basic types of reactions, combination and decomposition reactions. So let's begin. Now you might be wondering, how do scientists describe these reactions in a way that is simple, clear, and can be understood by anyone, anywhere in the world? Well, it's a bit like learning a new language, a language that moves from long sentences to simple, meaningful symbols. We could describe a reaction in a full sentence, just like this one. It is correct, and it tells us what is happening. But as you can see, it is quite long to write this every time. For science, we need something more efficient. So, a simpler way is to use something called a word equation. This is much shorter, and it shows very clearly what we started with on the left and what we ended up with on the right. The arrow in the middle simply means reacts to form or gives. And this brings us to two very important terms that you must remember. The substances that undergo the change, in this case magnesium and oxygen, are called the reactants. They are always written on the left side of the arrow. The new substance which is formed, magnesium oxide, is called the product, and the product is always on the right side. But the best way, the most scientific and concise way, is to use chemical formula. This is a proper chemical equation. It uses symbols for the elements and compounds, which makes it the most efficient and universal way to write a chemical reaction. Okay, let's now move to one of the most important skills in chemistry, and that is balancing a chemical equation. This is something you will have to do again and again, so please, let's understand it properly. But first, why do we need to balance equations at all? It is because of a very fundamental law of science, the law of conservation of mass. This law states that mass can neither be created nor destroyed in a chemical reaction. So this means the total number of atoms of each element must be the same before the reaction and after the reaction. They just rearrange themselves. Now look at this equation. This shows iron reacting with steam. Just by looking, you can tell something is not right. On the left, we have one iron atom, but on the right, there are three. And for oxygen, there is one on the left, but four on the right. This equation is not balanced. We call this a skeletal chemical equation. Let's just count the atoms to be sure. As this table clearly shows, the numbers don't match. On the left-hand side, the LHS, we have one iron atom. On the right-hand side, the RHS, we have three. For oxygen, it's one on the LHS and four on the RHS, so it is definitely unbalanced. So let's balance this step by step using the hit and trial method. First, we start with the element that has the maximum number of atoms, which is oxygen. We have 4 on the right, so we need 4 on the left. To do this, we place a 4 in front of each 2O. Now oxygen is balanced. But this has changed the number of hydrogen atoms. On the left, we now have 4 times 2, which is 8 hydrogens. To balance this, we will place a 4 in front of each 2O on the right side. Good. Now hydrogen is also balanced. Finally, let's look at iron. We have 3 on the right, so we simply place a 3 in front of Fe on the left. Now everything is balanced. And there we have it, our final balanced chemical equation. You can also see these small letters in the brackets. These tell us the physical state of the substances. S is for solid, and G is for gas. So we know that solid iron is reacting with water in its gaseous form, which is steam, to produce solid iron oxide and hydrogen gas. Very good. Now that we know how to write and balance equations, let's start learning about the different types of chemical reactions. We will begin with one of the simplest types, a combination reaction. Just as the name tells us, a combination reaction is a reaction where two or more substances, are reactants, simply combine to form one single product. You can think of it like this. Reactant A plus reactant B combine to give a single product, AB. A very common example of this is the reaction of calcium oxide, which is also known as quicklime, with water. When they react, they combine to form only one product, calcium hydroxide, or slaked lime. A large amount of heat is also produced in this reaction. If you touch the container, it feels very hot. And this brings us to another important term. Because heat is released, or it exits the reaction, we call such a reaction an exothermic reaction. Exo means out, and thermic means heat, so heat is given out. All right, let's move to our second type of reaction for today. This one is the exact opposite of a combination reaction. It is called a decomposition reaction. So, in a decomposition reaction, a single reactant breaks down or decomposes to give two or more simpler products. It's just the reverse of combination. Here, one compound, AB, breaks apart to give A and B. Now, to break a compound apart, energy is needed. This energy can be supplied in different forms. If we use heat, it is called thermal decomposition, like when we heat limestone. If we use electricity to break down a substance, like water, it is called electrolytic decomposition. And if we use light energy, like for silver chloride, it is known as photolytic decomposition. So, let us quickly summarize the main points we have learned today. First, chemical reactions always involve the formation of new substances. Second, all chemical equations must be balanced to obey the law of conservation of mass. Third, in a combination reaction, two or more reactants form a single product. And finally, in a decomposition reaction, a single reactant breaks down into simpler products. We have learned a lot today, but here is something to think about. We've seen elements combine, and we've seen them break apart. But what happens if one element comes and pushes another element out of its place in a compound? It's a very interesting question, and we will explore the answer in our next explainer when we study displacement and double displacement reactions. I will see you then.